Today we're going to be graphing linear inequalities in two variables. So we have graphed inequalities before. When we saw inequalities before, they looked like this, right? And we read that x is greater than 3. And how we graphed one variable, again today we're doing two variables, when we did one variable, we did that on the number line and we marked our point 3 there. Remember, since x is not equal to 3 but strictly greater than, we use the open circle. And then since x is greater than 3, we drew the arrow to the right. So when we have an inequality, we have infinitely many solutions because this line with the arrow represents, or ray I should say, represents all the solutions, the infinite solutions to this inequality. And that open circle on the 3 indicates it's not equal to 3, but that's like our boundary. And that line goes right up to the 3. So 3.00000001 is a solution to this inequality. Well, today we're graphing linear inequalities. In other words, we're looking at lines on the coordinate plane. Just like on the number line, we are going to graph the equal, just like we graphed x equals 3 here. Although it wasn't equal, it was strictly greater than, but that where it does, the 3 marked our boundary. And so here on our coordinate plane, our line, our normal line, is going to mark the boundary. If it is equal to, if it is also equal to, then it'll be a solid line. If it's not equal to, like the 3 was not equal to here, then we're going to use a dashed line. On the number line, we use the open circle. On our coordinate plane, notice here in this example here, this is the graph of x is less than 2x. So x is not equal to 2x. So the line here that's dashed is the line that represents y equals 2x, but it's not a solid line because it does not equal 2x. Since it's strictly less than, we do the dashed line. It's like the open circle on our number line. So, but then, just like we drew the arrow on our number line to the right to indicate all the values that were greater than 3, what we do on the coordinate plane is we shade the area. And so this shaded area indicates anywhere in this shaded area on this graph, those are all solutions to this inequality where the value of y would be less than 2x. We can pick a point here. Like, let's pick this point. This point is 2, 1. In other words, x is 2, y is 1. If we substitute in our equality, 1 is less than 2 times 2, or 1 is less than 4. That is true. So you can see any point we pick in that shaded area is a solution to this inequality. Well, let's do an example. So in this first example, we have y is greater than 2x minus 3. What we're going to do is we're going to start by graphing. You first start and we think y equals 2x minus 3, right? So just like we would graph that, we would start, here's our y-intercept at -3, our slope up 2 over 1, up 2 over 1. I'm going to make this a little bigger. I don't know if I can make it bigger. Yeah, there we go. We're going to go up 2 over 1. Now, here's where you have to stop yourself. Before you get out that ruler and draw your line, you have to look and see, is it equal to or not? In this case, it is not equal to, it's strictly greater than. So we're going to do, and you can still use your ruler, but just remember to make it a dashed line. So it is a dashed line. Now we have to determine which side of this line are we going to shade. Are we going to shade to the left or the right? So what we have to do is we have to test a value. And the best number to test is 0, 0. So test 0, 0. If it's not on your line. Here's 0, 0 right here. It's not on our line, is it? So we're going to test 0, 0. So just plugging in, is 0 greater than, well, this is going to be 0, negative 3. Is 0 greater than negative 3? Yes, it is. So we're going to shade on the side that includes our 0, right? That was a yes. We could, oh, I know, maybe let's do this. Maybe let's do yes, right? It was yes, so we shade that side. Let's take a look at another example. For this one, we have, initially we're going to graph y equals negative 3x plus 4. So that is a y-intercept of 4. Slope of negative 3 means down 3 over 1, down 3 over 1, down 3 over 1, down 3 over 1, up 3 over 1, and so forth. Now, in this case, it is equal to. So we're going to do a solid line through those points. And we are going to check, we're going to test, check 0, 0. Is that true or not? Well, when we plug in, we're going to, 0 is less than or equal to 0 plus 4. Or in other words, is 0 less than or equal to 4? Oh, well, how about that? Yes, it is. So we're going to shade where it includes that point. So you can see what we're doing as far as graphing the line is not a whole lot different than what we've done before. We know how to graph linear equations. Now we just have to remember to check, is that line going to be dashed or solid, whether it's equal to or not. And then we're going to test 0, 0 or some other point to see which side we shade. All right, let's try one more example here. Here we have a y-intercept of 4. Slope negative 2/3, so down 2 over 3, down 2 over 3, down 2 over 3, up 2 over 3 this way. There we go. Now, notice not equal to. So we're going to do a dashed line and make sure it's very clear to me, especially on the test, is it dashed or solid, right? Now, we're going to test 0, 0 to see which side we shade. So is 0 less than 0 plus 4? Is 0 less than 4? Oh my goodness, every single one, 0 was true. We need to do one where 0 is not true. All right, now we're going to do a right in here. I have a really tricky one for you. Really tricky. But I know you can do it. I know you can do it. What about this problem? Well, right now, it is not in slope-intercept form. So let's get it into slope-intercept form. We're going to subtract x from both sides. Negative 2y less than negative x plus 4. Now we need to divide everything by negative 2. Hopefully that red light and sirens flashing in your head, because remember, when we have an inequality, what happens if you multiply or divide by a negative? What do you have to do? That's right, we have to flip that inequality sign. So when we divide everything by negative 2, this is going to turn into y greater than 1/2 x minus 2. This is the hardest thing you're going to see, right? When you have to solve it, when you have to flip it. Well, let's see. So we're going to get, let's see, starting at negative 2, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, down 1 over 2, down 1 over 2, and so forth. It is strictly greater than, so we're going to do a dash line. Now, let's test. When you go to test 0, 0, always test back in the original equation. So remember, our original equation was this one right here. Because what if we forgot to flip the inequality sign? What if we made some mistake somewhere? So especially if you forgot to flip the inequality sign, testing with your original will make sure you shade the right side, even if, and hopefully that will enable you to see that you didn't flip it. So if we test 0, 0, we're going to get 0 minus 0 is less than 4. 0 is less than 4. Yes, again, one more time. 0 is correct, but it is above. And that is indicated there because generally, if y is greater than, it should be shaded above. If y is less than, let's compare. Y is less than, we shaded below the line. Y is greater than, it's above. Y is less than, below. In other words, the y values are getting smaller. So that looks good. We can see we remembered to flip it, and our graph, our shading matches our final equation here. So good luck, and we'll see you in class. Bye.